All right, I'm just calling Illinois sample 2 and California sample 1. So California had a sample of 250 households. So did Illinois. The X-bar for California was 4,777. Cal, how are you doing? Any questions for me? Okay.
Where'd you get 4,700?
This was supposed to be written in the problem. I didn't write it.
Oh.
Yep. I did write the standard deviations down, but I didn't write down the means or the ends. This problem literally says the two samples are independent, so that's helpful. And clearly n is bigger than 30, so we're good there. So step 1 is also a nice time to kind of set up all your data that you're going to use. All right, step 2. Step 2 is state the null and claim. Null and alternative and the claim. That's H sub O, H sub A. All right, so step 2 down here. Now what we're going to do is we're going to write out the H sub O and the H sub A. So H sub O, H sub A. So it looks like their claim is that there is a difference. What does that mean? What does it mean when they're saying there is a difference?
Dependent or?
No, like instead of saying something like, I think that California has more debt than Illinois, they're just saying that there is a difference.
But minus.
What'd you say?
They don't know which one has more or less.
That's true, but they don't think they're the same, right?
Not equal.
Right, not equal to. So I'm going to say mu1 is not equal to mu2 here for my H sub A. And for my H sub O, I'm just going to say that they're equal to each other. And my claim is down here. Okay. With step 3, we need to figure out the critical values and the rejection regions. 1, 2, 3 after that, yep. For this, you're going to use A16, and you should also draw a picture. Okay. It's a pretty good bell curve, right? I believe we've all found the appreciation of drawing a good bell curve, right? I'm pretty proud of this one. I mean, it's no triangle, but.
Yeah. Simple.
All right, so it says here that alpha is 0.05, and what do you think? Left-tailed, right-tailed, two-tailed?
Two-tailed.
Good, how come?
Equal sign.
Yep.
Why? It's average.
You got a good one?
Well, it's a little fat on the top, I would say.
Okay, yikes.
But, I mean, it's decent.
Yes, I mean, it's fine. No, I mean, it's
I
fine.
I would be happy with that, yeah.
Don't ask her how your outfit looks. All right, so if we go to A16, everybody have their tables?
Yes.
What area are we looking up in each tail?
.95 or .95.
Not quite, because remember, how much is in every tail? Because 5% is in both tails, so together the two tails make up 5%. So what area is in one tail then?
.25.
Right, so you're gonna look up .025 and .975 if you wanna go that far. .025 is, I got negative 1.96. And then it's symmetrical, so this is 1.96 over here. All right, next up, we've got to find the standardized test statistic. Okay, now this is going to be a big formula, so you're going to need to kind of like make room for it.
Wait, is that all square? I mean,
That's a sigma squared 1, sub 1, and a sigma squared sub 2,
is that going up?
right? Now, you're going to find that they do this on the AP test as well when you look at the formula sheet. And by the way, I will take a day where I just go over the formula sheet with you and how it looks on the AP test. But look at this. This is how they do it in the book, and this is also how they do it on the AP test. They have that top that's the same where it's like x bar 1 minus x bar 2 minus mu 1 minus mu 2. And on the bottom they say figure out the standard error, and then they have the standard error on a different location. You see what I mean? So I just put this stuff underneath that because that's where it goes. They just didn't want to write it out as one big piece because this gets used frequently in this chapter, and then this keeps changing, like what's underneath. And so they will have that on the AP test where it's like in two different places and you have to combine them together, but I'll show you how. All right, so let's find that test statistic. All right, let's write it out. Here we go. First, we're going to do x bar 1 minus x bar 2. So 4,777 minus 4,866 minus. What do we normally put in for mu when it's x bar minus mu?
So like the thing that they say, the thing
The
that
claim, yeah, the claim that they say, right? But the thing is that this time there isn't one. And so what we do is we assume that they're the same. So we're going to say that mu 1 minus mu 2 is just 0. And by the way, this is always what happens.
There's always 0.
Why do they even have that in the formula? Yeah, because normally, so you know how, like, they're trying to connect it with how all these formulas are essentially x minus mu over sigma. It's just the sigma keeps changing. The x and the mu keep changing. So they're trying to relate it all to kind of the same thing. Do you see what I mean? Okay. Do you guys, when you're done, want me to print out the notes for next time and you just to move ahead? Or what do you want to do? We'll chill for a moment?